All right. Welcome everyone to the ACSI spacecraft seminar series on automating SysML using macros. My name is Josh Buettner, and today's date is May 28th, 2023. So let's dive in. All right, so the basic gist of this seminar is going to give students a brief overview of one of the tools that they can use when automating some of the more tedious and menial tasks in SysML. As they learn more about modeling and both SysML and UML, this could come in handy as the models become more complex. So the goal of this is to give a very high level overview of the capabilities they have when trying to automate things using macros. So first, before I dive in, let's go over a brief agenda. So I've got first a brief introduction. Then I'm going to get into a quick background of myself and sort of the background that the students should have when listening to this. And then I'm going to get into 3 lessons. The first one will be on an overview of how to implement macros in SysML. The second lesson will be on how to import files and some notes on debugging and some tips on that. And then the third lesson is going to be on generating packages and blocks. And then I'll close things out with a recap and some takeaways. So a little bit of background. First, my name is Josh Buettner. I got my aerospace engineering degree at Iowa State, my bachelor's degree, and I'm just finishing up my master's degree in aerospace systems engineering at UAH. I currently am working at the Complex Systems and Integration Laboratory, or CSIL, at UAH, but that's about to change as I will be starting a new position at Blue Origin as a systems engineer in this coming week. So the students that are watching this, you guys should, in order to understand sort of the stuff I'm going to be talking about, you should have some basic knowledge of SysML, the systems modeling language, and of UML, or the unified modeling language. So specifically for this course, you should know what a block is, what a block definition diagram is, and you should know what packages are, and you should have some knowledge of the meta model when dealing with SysML. Not like a super in-depth knowledge, but you should know what you're looking at when I show pictures of these things and what I'm actually generating and why it's useful. In addition to that, you should also have some very basic knowledge of programming. Don't worry if you're not like super familiar. Just some basic knowledge of either Java or Python will definitely come in handy. I'm not going to get super in depth to like the software and programming stuff here, but it's helpful to understand some of that material. So some motivation for why we actually want to learn about this and why we want to harness these capabilities when modeling things. As our models become more complex, they get more complicated, and editing the models and modifying them can get very tedious if you have a big model, or if you're modeling a certain type of system over and over again, and it's and you want sort of like a base structure for a particular system. How do you sort of create that over and over again without having to do it again and again every time? So here's a very brief example that I created. It's like a simple propulsion system in a block definition diagram here on the right, and then on the left here's the package hierarchy I've got going. And as you can see, this is a pretty simple propulsion system, but it's already very complicated. Lots of packages inside of packages, and we got value properties and associations, all this stuff. So generating something like this and then doing it again, just doing it by hand or through the GUI, you're going to be doing lots of clicking and dragging and things. So we want to kind of alleviate these tasks, make it a little easier to do, or make it a little faster, more efficient. So that's really what we're trying to do here. All right, so lesson 1, I'm going to give a really brief introduction to how macros work and how you can implement them in SysML. So here we've got, so when you go into the tool, when you're in Magic System of Systems architecture or whatever tool you have using SysML. You go over here to tools and then macros and organize macros. It's pretty easy to get into there. You can go ahead and create a macro, or you can organize it. And you'll see me do this when after I go through this, I'm going to do a brief example, and I'll do an example for all three of the lessons here. But for now, I've just got the pictures. So once you go into organized macros, you can see all the macros that are in the model. That you can either save them in the model, or you can save them locally to a file. Either way works. And then when you're here, you can either run them from this point. You can click on one and run it, or you can add, edit, or delete macros in here. See, I've got three right here that are loaded up into the model I already created. But if you click on edit here, then you get into the macro information, and this is where you can edit the name. You can select the language. All of the programming languages for this are Java based. So I've got them listed here. We've got JavaScript, JavaScript Rhino, Bean Shell, Groovy, JRuby, and of course Python, Jython. Jython's the one I'm going to be using because I'm familiar with Python, and Jython is basically Java and Python put together. It's the Python syntax, but implemented through Java. So it's, yeah, if you know Python, this is definitely the way to go. So here, the other important thing is under file, you can specify the local path to the file, and that's very handy, as you'll see in a moment here, for saving and editing. And then a description, it's usually good to throw in a description of what your macro actually does. And of course, at the bottom here, this is a nice little feature. You can assign a keyboard shortcut to running the macro. So you don't even have to go through all of this. You can literally just assign, in this case, I've got Control B for this current macro, and then you can just quick run it with a click of a button. So another thing to point out is one of the difficulties with writing macros is dealing with the No Magic Open API. It's kind of hard to understand. There's a lot of information, and I would really recommend going through and reading some of this and delving into some of these links that I have here. So I've got the developer's guide. That's a basic general overview. The macro engine documentation. We've got, there is a community forum. There's not a whole lot of activity on there because what I'm showing you today isn't like common practice yet. So there's not going to be a ton of examples for you, but there are some that exist. So you can look at the community forum. If you're curious about Jython, like I said before, it's basically Python syntax, but there is a web page there's a wiki for the Jython documentation. You can check that out. Also, there's an general overview of the Open API, and I've got that link here as well. All right, so some quick helpful tips. First of all, and you'll see me do this when I do the live demo here. The No Magic or the macro user interface in the tool is kind of terrible, and you'll kind of see why in a moment here, but there's not a whole lot of color differentiation between functions and other things. And also there's a weird thing where how spacing works. It can really, if you're copying and pasting code, it can really screw up your code and add a tab or a space where there's not supposed to be one. So I would recommend using another editor like Visual Studio Code. That's what I usually use. It's visually much more appealing than using the user interface that's actually in SysML. So you can use Visual Studio Code. You could, if you're running, if you are writing with Jython, you can open your code in idle. You can't run it there, and same with Visual Studio. Here you can't run it in here technically, but you can save it, and as long as it's saved to the same place that you saved it when you created the macro in SysML, then it will, if you save it, then it'll, you can just run it in the tool and it'll work just fine. And you'll see me do that when I do a quick demonstration here. The other bit of advice I would say is create functions. And this is just general programming advice. Like when you're writing long, giant codes, you can kind of see here, I'm defining lots of functions in this code here. I've got two at the top here. it's good coding practice. Otherwise your main code's going to get really, really big and long when you're doing some of these. So it's good to have functions just kind of created and defined, and then you can save them locally and call on those functions later. All right, so that was lesson 1. That was just a brief overview. So for lesson 2, what I'm going to do is, well, first of all, this lesson, I'm basically going to show you how to import a CSV file and then print out the contents of the CSV file in SysML. And you'll see why that's useful here in a second. But first, I'm going to exit out of that. And we're going to go into SysML here. So we've got the tool here laid out. So as I showed before, this is just a SysML model. And if we go up to tools, down here to macros and organize macros, as you can see, I've already got this one, the one I'm going to show you, completed, but I'm going to kind of build it up from scratch and just to show you all the steps and explain everything as we go along. But as you can see, I have this one already here. But what we're going to do is we're going to hit, you can either hit add right here to create a macro, or if you wanted to, you could go tools, macro, and create macro. So let's just click on that, create macro. And as you can see, we've got our user interface here, and we've got in this window here. And so here's where, make sure you select the right language. Otherwise it's not going to make sense when you start coding. So I'm using Python. So we're going to select the language. And like I said, I've already got these laid out here. So the first thing I'm going to show real quick is how to access the GUI log, essentially, and that, or the notifications window. And that's going to be really useful for printing things out, and it's really useful for debugging. And so in order to do that, you basically need, it's a long command, and I've got it here. I just copied and pasted it because if I type everything in live, then it's going to take a long time. You guys are going to have to sit and watch me type everything, and if I misspell something, then it's just going to be awkward, and I have to debug everything. So we got this whole thing here: application dot get instance parentheses dot get GUI log parentheses dot log, and then I've got a variable X in here. So now, in order to run this, we need this thing called application. And so we have to import that. So let's create another line here. And again, it's the Python syntax. So we're going to say from com.nomagic.magicdraw.core import application, and also make sure there's capital A right here. So in order to run this, you would need the application here. So, and like good programmers, the first thing we're going to do is we're going to print out everyone's favorite hello world. So instead of the variable X in here, I'm going to type in a string, hello world, close the parentheses. All right, and this should be good to go. What you can do is you can either hit save at this point, or we can you know what, let's just run it and see what happens. All right, so if we hit run, and as you can see down here, we've got the notification window pops up, and our string hello world popped up here, and then it'll always issue this it'll always say this: the macro quotes untitled has been executed. Whatever you call your macro, that's what it's going to list out when it actually runs successfully. So hey, we got our first program done. Okay, so, and as I said before, it's a good idea to turn this into a function. So let's do that. So we can tab, and whoops. This is why I don't like using this user interface here. I'm going to switch over to Studio Code in a second here. And we're going to call this one print. And I know what you're thinking. You're probably thinking, well, doesn't Python have a print function? And you're right, but technically you can't print out to the notification window. If you use that print function, it's not going to know what to do with it because we're using Python in SysML here. So let's change this to a variable and make sure that matches there. And then we're going to define a main function. Tab there. And we want to call this print function. So we're going to print world. All right. And this is, just generally good coding practice here, where we want to create a function that does this. So then every time we want to print something out in this code as either as for debugging purposes or for troubleshooting or whatever, then I can just, instead of writing this whole line in every time I want to do that, I can just write in print and then put the string that I want printed out. And this has to be a string when you do when doing this whole line here. This X variable has to be a string. That you can't print out an integer to this here, but you can, if you have an integer that you want printed out, you can very easily convert to a string. So, all right, so this works. And just to make sure it works, we're going to clear, if we want to clear this notification window, we just hit this little button here with the eraser on it, and it clears out that. All right, so what we're going to do is just make sure it works again. So let's run. Uh-oh. This is why doing it live is kind of, I have to, so I got an error there. And so the problem was this define main. I didn't have a colon at the end of that. So again, I won't be doing this for all of them, but all right. And the other thing I need to do is call main function. This is probably infuriating for some of you that are more experienced programmers, but watching me do this live, that's why I'm going to be copying and pasting a lot of code in. So, all right, here we go. Hey, there we go. Now it works. Okay, so, but that's a very trivial example. What I should probably show you is how to some good tips when saving this. So if we hit save, then we get to the macro information here, and this is where we can name it then. So let's call this ACSI example. All right, it's going to be Jython. Now the file, this is where we can click on the little three dots, and then we can specify the path. And I'm going to save it locally. You can also, if you see here, you can say add macro to model. That's pretty useful if you want to save a macro to the model and have it just saved there. And then you don't have to store it locally and have people share the macro and with the actual model to run it. So let's go, and I've got a folder set up. So let's go SysML automation. And then here's where you can specify the file name. Now keep in mind the name of the macro is not necessarily going to be the same, is not the same thing as the file name. I think it's a good idea to call them the same thing so that you don't get them confused and you don't know which macro is associated with which file. So I'm going to call them the same thing. ACSI example. Okay, and it's going to be saved as a .py file. So like I said, you can open this in Python. You can open it in idle and edit it and save it and then run it in the model, and that works just fine. So I got a bunch of them saved here. So let's save that. Okay, description. This is a test for the ACSI lecture. Okay, I don't need to get into super gross detail. All right, and let's add a keyboard shortcut to this. So what we do here is we go down here, new keyboard shortcut, and let's see what's not being used. Let's try Control J. Okay, Control J is not being used. So you have to assign a keyboard shortcut that is not currently in use. So like control C, is to copy something. So you can't do that. So we're going to do control J, and then make sure when you do that, even though it says success down here, you want to hit assign, and then it shows up here, and then you're good to go. And you can obviously remove it if you want. So now we're good to go. So let's click OK. And then at this point, it'll ask you if you want to save this macro, save untitled. You don't have to, because it'll just save this. It's the same macro that we were just running. So we're just going to hit no there. As you can see, ACSI example is currently in there. So let's close out of that and let's try the keyboard shortcut. So if we go Control J, boom, there it goes. Okay. So let's clear out of that. And so as I mentioned earlier, it is kind of annoying to work with the user interface that's in SysML here. So what I'm going to do is I'm going to open what we just created in Visual Studio Code, because I saved it locally. As long as I save it in the same spot, it'll know what file I'm talking about. So if we this, and I already have Visual Studio Code opened up, and you can download this Visual Studio Code. You can install it if you're on a UAH computer. I know not all of you are UAH students, but it doesn't require admin permission to install, so you can just go ahead and install it. And it's free. So it's, as you can see, much more colorful, much easier to look at. It will automatically tab things for you if you define a function. As you can see here, I've got a bunch of functions defined. And this is where I'm going to be pulling my code and examples from. But we're going to start from scratch. And let's go. So file, open file. All right. So ACSI example. That's the one we just created. Let's open, and there we are. Let's create a little bit of space here. All right, and this is what we just created. So as you can see, it's easier to look at and read code in here rather than in the model. So I'm going to be editing it here. You can't, like I said, you can't run it and you can't really debug in here, but you can, as long as you save, you just hit Control S, and then you can click over to the model here, run it, and it'll run just the same. So, all right. The next example that I want to demonstrate here is, well, we're going to create another function, and this function is going to import a file, particularly a CSV file, which can be very useful, and you'll see why in just a moment. So I'm going to copy and paste this in here. All right, Control V. All right, so we got a big giant mess of code here. Don't worry, it's not too bad. All right, so in order to open the file, what I'm doing is I'm creating a pop-up sort of button selection. So you can either open the file, browse for the file locally, or you can insert the file path, and that's what I'm essentially doing here. This don't worry too much about this specifically. This you can literally just copy paste this function. It'll import the file. So the only input argument we have here is name, which is just the name of the what the actual option pane is going to be. Because the file, it's not going to be the file. That's going to be specified when we actually run this. So, all right. The only thing of note here is we've got just an if statement. So it knows if one button is clicked versus another, it will do a certain thing. And if not, it'll do another thing. So, all right. So let's see what this does so all we have to do, so I've added this in here. So I'm just going to hit Control S. That'll save it. And then if we go back over to the model here and I hit Control J, whoop, it didn't. Hold on a second. Why didn't that? Yeah, it should be good to go. Here, let's try that again. That's funny. Oh, you know what? Figured it out. Dumb mistake. I didn't even call this function. I defined this function, but I never call it. Silly me. All right, so we actually have to call this function for it to do anything. So we've defined it. We've called it import file. So let's do that. Import file. And the name, honestly, the name could be anything. Let's call it, let's do what I did over here. All right. So now, because I have my main function right here, highlight that. This is the main function where I'm calling both of these functions. So what we're going to do is it's going to print out hello world, but it's also going to import the file. And the actual, I should show you the actual file I'm importing. That'd be good to know. So let me pull that over here. So it's a CSV, but I have it open in Excel right now. You could open it as in a in Notepad, and you would see that it was comma separated. But you can create a CSV in Excel. Just make sure you save it as a CSV. And so these are just the names of a like basic components for a propulsion system. We have our liquid propulsion system, main prop, reaction control system, so on, and then just arbitrary numbers associated with those. So we're going to import this into the model, and that can be very useful, as you'll see later. Pull that over there. Okay, so let us, hitting Control S, you can clear out of that, and then Control J. Uh-oh. Oh, you know what? This is also, yep, this is why we do these things live. Okay. So the error that came up is because, so note, remember from this function up here in the print function we created, we have application, and we had to import that. Well, in same thing in here, we have J option pane, which is which we haven't defined. We have to import that. And J file chooser, same thing. So all we have to do, and I have these predefined, so all I have to do is copy and paste them over. So we've got, we're accessing JavaX swing. So importing J option pane and J file chooser, and also the file system view. So you've got, if you're getting errors like I was getting a second ago, you might not, it might be because you don't have something specified or imported. So now it should work. Let's try that again. So Control J. There we go. See, this is, so I created this little pop-up here that came up. So it'll say input file for names, and that's the CSV I'm referring to. We have the option to browse local file or specify the path. And so I'm going to do browse local file because I have the file saved here. So right over there, and I have it saved in test files, and it's called unit numbers, which is kind of a weird name, but whatever. And then we hit open, and it ran. So, all right, didn't get any errors, but you're probably thinking, well, how do I know that I actually imported this thing correctly? How do I know that it's imported in our model? How do I tell that I did this correctly and that it actually came out correct? So, well, that's why we have this print function, and we can test to make sure that we imported this correctly by printing out the contents of the CSV in the notification window to make sure that it is correctly in there. So I'm going to brush over some of the details of this, but basically what we're going to do is we're basically going to create a in Python what's called a dictionary with our, and populate our CSV contents or we're going to populate the dictionary with our CSV contents. So in order to do that, I'm not going to go into that with super heavy detail, but essentially, let us Control C, and we're going to put this in our main function here. Let's add a little space here, and we want to make sure we're tabbed correctly. So, because when you define a function in Python, everything's got to be tabbed one over from that. So, and this one needs to be back. All of these need to be back. So this is the nice thing about editing in Visual Studio Code. It'll tell you when things aren't quite right, because I have the Python extension installed here. So definitely helps when you're editing code to do it in this way. So basically this these two nested for loops with this if statement, all this does is take the contents that we imported in our CSV and puts it into a Python dictionary. It gets a little bit complicated to wrap your head around, but you can practice. There's plenty of documentation on dictionaries in Python. I'm not going to get into that in this lecture. So you guys go ahead and feel free to look into that yourselves. So what I had to do in order to read a CSV, I have to import CSV, because this is within Python that you have the import CSV command. Up here, we are importing stuff from Java that we had to use. Down here, this CSV reader is in Python. So we're already we just have to import that. Okay. And I forgot one line of code. There we go. Okay. So for now, I'm going to comment this one out. So what we've got here, so what this what this code here should do is import the CSV and then creates a value dictionary, or what I'm going to call a value dictionary, which is just a dictionary, and I'm defining it here. And then we're setting the keys of that dictionary to the names that I showed over here in this Excel. That would be, these names here are going to be the keys, and then these values will be the underneath those keys, because then with a dictionary you can grab values by indexing the keys essentially, and you can loop through them as you'll see in a moment here. Okay. So what we want to do now that we have the dictionary, what we want to do is print out the contents of the dictionary. So hold on a second. Let me open this up. Yeah, because I did this earlier and I don't want to redo stuff that I've already done. So, and make sure we're in the right, whoops, there we go. Okay, so basically what we're going to do, we create a little for loop here. So for K in our value dictionary keys, so we're looking at just the keys in this value dictionary we created. And we're defining a variable called value is equal to, we're indexing that particular name that we're iterating on, or the keys that we're iterating on. And then we're going to print out, we're going to use our print function that we created up here to print out both the actual key, K, and then a semicolon, and then a string with the actual value. And so what it should do is print out it should print out the contents as you see them in the Excel spreadsheet as that CSV. So let's go ahead and Control S. Okay. Let's clear out of that and Control J. Okay, we got to specify the file. Go into here, test files, unit numbers, open. I see what happened here. Let us actually cancel. Yeah, it's going to throw an error because I think I have this twice in here. Yeah, so I need to get rid of this line. There we go. We only want to do it once. Don't need to do it twice. Okay, because I had the import file. I was calling that twice. Okay, let's try it again. Control S, Control here, Control J. Browse for the file. And if you're running a code where you have to do this, what I would suggest is just have the path to your test file hard coded in, so you don't have to click through when you browse for the file every time. That'll save you a lot of time. But then when you actually implement the code, you can sort of re-implement those capabilities. But all right, so and look at that. So if you look at the notification window now, we whoops, oh boy, there we go. As you can see, it's printed out all the contents of our CSV. Let me pull that into the window here just to make sure we did this correctly. Let me pull this up so that you can see it a little bit better. So yeah, look at that. So we have propellant motive system. As you can see, the order is slightly different, and that's something to keep in mind when you're doing this. There is a way to get the order if you want it in this specific order. It's a little tricky, but there is a way to do that. I'll let you guys tackle that problem on your own, though, because with Python dictionaries, it doesn't populate the dictionary, or the order can get mixed up. It really depends on how you implement the code. But there is a way to make sure the order is correct. But yeah, so made sure that turned out. So let us now go back to our code. All right, so what I showed in this example here was we imported a file. And then we printed out the contents just to make sure that we actually imported the contents correctly. So yeah, that's a good these are both very handy capabilities to have when you guys do this in the future. So with that, you go back to all right, let me get back to where I was at with the presentation. Okay, lesson 1 is done. Oops. Didn't want to do that. There we go. No, I didn't want to click on the link. All right. Lesson 2. And all right, now we're on to lesson 3. So now we're going to actually start getting to the meat of this, the generating the packages and blocks. So we're actually going to be working with the model and generating elements. So in this lesson, I'm basically going to demonstrate I'm going to show you how to create a function that creates packages, and then a function that creates blocks, and then also naming those blocks and packages. So, okay, exit out of that. Back to here. Back here. Okay, so first thing we're going to do is get rid of this at the end here, because we don't want to print off these. So actually, what we could do is, well, we'll just get rid of it for now. All right, so we're still going to want to import this because we'll want to use these names to, when we generate our blocks, we'll want to name the blocks with those names. All right, so first we want to define a function that will generate a block. And you would think it'd be pretty intuitive, right? Like you just say, there's got to be a command that says, oh, generate block. And unfortunately, it's not that simple. You got to treat your the API here like a really smart kindergarten kid. It doesn't know, or it doesn't know anything, but it's very smart. So you have to be very explicit when dealing with this. So here's the basic setup here we've got for a block generation function that I've defined here. So I've called it block generation. And it's going to return a block inside of the containment tree in SysML. So let's go line by line here. So I've got these input arguments, and you'll see what those are in a moment here. The block name is pretty self-explanatory. The pack, that's short for package. proj is short for project, and fact is short for factory. And you'll understand what those mean in just a sec, but I'm going to go line by line here. So first of all, we're going to define an object called block. That's going to be our block. And we first need to create a class instance before we can do anything, before we can generate an element or anything. So, and in order to do that, we need to access what's called the elements factory. And that I'm calling it fact right now. But when you do that, then you can access this command, create class instance. So let us first, in our main code here, define some of those things. So this factory has to be factory is equal to our elements factory, and we have to get that from the project. Now, as you can see, it's highlighting it here because I haven't defined project, so we need to define that. And so it's just going one step at a time. The project we can get with this command, project, we can get the project from the project's manager. So get active project, that's the command you use to get the current active project, which is I've only have one currently active right now, and I'm using the project's manager, but again, it's highlighting that because I haven't defined that either. So the project's manager, we can define that with this command, project's manager equals application. Now, remember when we defined the print function, we also used application. So we already have that one imported. Get instance, get projects manager. So those are the two. We have to get an instance of the projects manager, and then with the projects manager, we can get the active project. With the active project, we can get the elements factory. And when we have the elements factory, that's when we can actually access elements to implement into SysML here. Okay, so we've got that defined. So let's go back to our block generation function up here. Block, so that's our object we've defined as our block. There's a command called set name, as you can see here, as pretty self-explanatory. You set the name of your block to block name, and block name is just a string that I'm going to input to the function. We are going to set the owner. You have to set an owner. And in this case, I'm setting it as pack, and pack is just going to be the package that is going to contain this particular block. In this case, what we'll probably do after I get through this one, I'm going to talk about, we'll show you how to create a package here in a second, so that we can actually input a package into here. After we've done all of that, the next thing that has to happen is we have to apply the block stereotype, because if you just do these three commands, it's technically still not a block, even though we've called it block. It's not it has to have the block stereotype. It's just a class instance at that point. So what you have to do is define that stereotype, find it. So we need the stereotypes helper in order to do that. And with the stereotypes helper, we have a command called get stereotype. And then we have to specify the project, and then you have to use the correct string name for that stereotype to input into your stereotype. And then once you have the stereotype, you can add the stereotype, as you can see with this command, to our block, our object that we are calling block. And then you add that stereotype to it. And then at the end of this, we can return a block, and it should show up in our containment tree. So we need to import this stereotypes helper. So in order to do that, we are going to need this line up here. So let's, again, at the top, we're from com.nomadic.uml2.ext.jmi.helpers. You can import stereotypes helper and also the model helper, which I may not be using in this particular example, but we'll see. So yeah, now we've defined the stereotypes helper, and we can use that down here. Okay. So at the end of this, we want to actually call this block generation function. So if we go down here and we go block generation. And as you can see, because I spelled it wrong, I didn't include the underscore, but it's helping me out here in Visual Studio. I can click on that and it'll correct it for me. So very handy. And then it'll also tell me how many all the input arguments I need. So I need the block name, which we're just going to call it name. And we're just going to, define a string, comma, the package that we want to define. We're just going to say package, and we're going to have to generate that package, but that's well, we'll do that next. Then the project. So I've defined the project right here. I've gotten that from the project manager. So let's put that in. And then fact is looking for the factory. So the project factory, or the elements factory, I've defined right here. So we just got to do factory. As you can see, it's giving me a warning because package is not defined, but we're going to do that in a second here. So this we've called our package, or our block generation function. But before that, we need to define the package. So let's create a function which creates a package. And luckily, packages are much easier to create. You don't have to apply the like a stereotype to those. So it's a lot simpler. And I'm going to copy and paste that. Oh, we'll put it right here. Why not? You can live next to the block generation function. All right. So as you can see, it's very similar. We don't have as many inputs. Like I said, we don't have to apply this stereotype to it. So that gets rid of these 2 lines of code. And this one's pretty straightforward. So it's also an element. So we have to access the elements factory, and you can create a package instance. There's a command for that. And all of these commands that you're seeing here, remember the slide I showed you with all the links? Like that's where you find all of these. If you're wondering, like, where do I find stereotypes helper, get stereotype, and all of these commands, that it's all in the documentation. So you got to hunt for it, but it's pretty, it's all there. All right, so we were on the package here. So again, set name, really easy. And we're calling this object pack, which is our package. And we're going to use the pack name, and that's going to be the name, obviously, and then the owner. And the owner is going to be just the model. You can set the owner to another package. So if you want like a nice little package hierarchy, you can put packages within packages. All right, so let's call this function, but we're going to do it before we call the block generation function because the block generation function needs the package input here. So let's go package creation, and yep, there it is. So we need the factory first. So we've already defined that. It's the same thing that we input into here. So factory, and then the pack name. And we're going to call this, let's call it, we're dealing with a propulsion system. So let's call it propulsion package. Why not? All right. And we need the owner, and the owner is just going to be model. Now, I don't think I have that defined. Hold on a second. Yeah, so we need to define the model as the owner, and we could do this for the block generation as well. We could just put model in here, but we need to specify what model we mean. So in order to do that, we need to access the project like we did before. And then there's a command called get primary model, and that will give us the current model that we are dealing with. And so that's going to be that's going to be our input into the package creation, as you can see here. And what we're also going to do is we're going to assign this to an object called package, so that we can input it into our block generation function here. All right. Another tip real quick before I run this, before we test it. So the thing is, so I have 4 inputs and 3 inputs here. You could simplify this and define all of these things here inside of the function up here. That could be better. I don't know which one's more efficient, but it would decrease the amount of inputs you have. And then let's say like you generate a block and all you have to input is the name and the owner, or like a package. And all you have to input then is you don't have to input model, because it's just going to be whatever. It's just going to be the model automatically. You could do that. There's a few different ways. If you come up with a more efficient way to do this, then by all means use it. So, all right. So this should be good to go. Let's test it out and see what happens. So I just hit Control S, make sure you save over here. And then we're going to Control J. We still have the file finder. We're not using it currently, but we are going to just run through this real quick. And open. All right. And macro ACSI example has been executed. So as you can see over here, look at that. We've got our package called propulsion, and you'll see ones that are newly added are highlighted blue or edited. And so if we expand this, look at that. We've got a block. So if we were able to, so if we created a block definition diagram, so we go over here and we go block definition diagram, and we'll call it propulsion. Then we could just, and we have this automatically, and we click and drag it in there, and we've got a block called name, and it has the block stereotype applied to it. So, all right. Now that seems pretty, you're probably thinking, well, that seems like an awful lot of work just to do one simple thing that we could have done pretty easily. But when you have a really complicated model, or if you want to generate like 10 blocks, it can really come in handy. And if you want to import, call those blocks something that is imported from Excel, it can really chop down the amount of time you spend if you have a tool that can do that. So before we proceed further, one other thing I want to show you real quick before we, so let's say, for example, that we run this and then we create the package, but we want to run it again, but we don't want to create the same package over again. So what you can do is create a test essentially to say, if the package already exists, then just use that instead of creating it. Because if I keep running this over and over again, it's just going to create another package called propulsion, and you're going to have a bunch of them. And that's not very good modeling practice, because you're going to have, it's going to be confusing. You're going to have a bunch of packages with the same name. So first of all, let's delete this one. And so what we can do is Control C and okay, and let's get rid of this line here. Okay, so instead, what I've implemented here is a little checker here. So it's a simple if statement. If it exists in the model, then don't create it, and if it doesn't exist, then do create this package. And the pack name, we're going to call it same thing, propulsion. Why not? All right. So basically what it does here, we've defined data package. We're using the model helper again, find element with path. And that's a very helpful little command where it'll look for an element with a specified path. And we're just looking for it. We're looking for it in the model. If it's much deeper down the path, then you'd have to specify that. There is another way to do this, but with what's called a finder, but which is a little bit trickier to use. But for now, we're just going to use the find element with path. It's pretty straightforward. And so we have a simple if statement: if data package equals none. So basically, if this comes out to none, where like it looked for it and didn't find it, then we would basically run that command that we just created, where we call our package creation function, input all the input arguments, and call that package, input that into our block generation down here. If it does exist, then we just say package is equal to whatever this thing found. So let's try this. So just Control S, Control J, browse local files, SysML automation test files. Okay, so we've run it. It ran okay. We have our propulsion, we have our block called name. That's all good. Now let's run this thing again. Run again. And let's go. It's going to ask me to do this again, which isn't really necessary, but we'll just do it real quick. All right, and it's been executed again. As you can see here, it executed it again. But if we look here, see, look, it didn't create a new propulsion package because it found this one. It did create a new block because we haven't implemented the checker for, we could do this. It would be literally the same exact thing, but implemented for the block. I'm not going to do it here, but for an exercise, you guys can do that on your own. But yeah, so that's a good way to, if you're working with the same model over and over again, you don't want to create duplicates of things. It's a simple way to add a checker in there for it. All right. So I'm going to delete that, clear that. All right, that just about wraps it up. I think there's one more thing I want to demonstrate though. Okay. Oh yeah, so what I was going to show next was, so let's say we're importing this this CSV here, and let's say we want to add the we want to add blocks. We want to add blocks with the names of the contents of that CSV. So we can, that's pretty easy once we have the dictionary implemented. So instead of block generation here, so I'm just going to comment that line out. Let's add a for loop. Let's put this block generation thing in a for loop, and we're gonna use the keys from our dictionary. So we already defined our value dictionary keys. So we're just iterating over the keys, and we're going to put that as our file, as our block name into this block generation function. So hold on a sec. I want to make sure we're all good to go here. Yeah, that should be good. Okay. So let's, that should work. Let's go ahead and try and save that. And let's try and run it. Let's see what happens. Control J, browse local files. There we go, test files, units and numbers, and open. Okay, so it ran, no problems. We have our package called propulsion. And if we expand it, voila, look at that. We've got all of our, let me pull the CSV. So we imported this CSV here with these values here. And then we created a dictionary in Python with these. And then we took the keys here and we created blocks with the names of each of those, each of these here. So now when we've got our, so if we create a diagram, let's create a block definition diagram. Now we can throw these guys in here. We've got all of these defined already. So if you have a system that is, and this was much faster than me going through one at a time. Let's say for instance, this was like not just 10, this was like a real system, like dozens of these. You could create them one at a time, or you could create a tool, a macro that can import the names and create the blocks automatically for you. And then all you got to do is click and drag the ones you really need for a specific BDD into your BDD, and then create the associations and all that stuff, which you can also automate. It's beyond the scope of this lecture, but that's something I would recommend looking into. Automating, creating other elements like relationships, generalizations between these. So yeah, pretty handy. And of course, you can apply the same check system that we had for the propulsion package here for all of these. So if I run this again, it will basically generate duplicates of all of these, but typically you don't want that, because that's just confusing. Which one is the right one? Which one is the correct gas tank? So I'll let you guys do that on your own though, because that's a good exercise. You should have all of the tools and capabilities to do that. All right, so I will also attach the this code so you can sort of actually open it and look in with it. This code should be attached with the lecture. All right, so with that, let me go back to our presentation. Oh, come on. There we go. Get back to the spot I was at. Lesson 2 done, lesson 3 done. All right, so let's quick recap of what I talked about here. So I gave you a basic introduction into using macros for automating sort of the menial tasks in SysML. I gave you 3 kind of basic functions / macros that you can play with and that are very useful, and sort of laid the groundwork for you to expand and make them more efficient and implement into your own models. I also gave you some really some useful tips as someone who kind of jumped into this on my own when I and didn't really have a ton of help when doing this. Some things I wish people had told me when I was starting out with this stuff. So the key takeaways here: macros are very helpful for the menial tasks when modeling. They can also be useful for documentation purposes. If you want to say find all of the blocks in your block definition in your block definition diagram and like list them out in like a printout, you can do that. You can look for specific ones if you've got a really big model. There's lots of stuff you can do with this, so much that I cannot cover. I can barely scrape the top with this lecture. Keep in mind though, macros are useful, and what I showed you is useful, but it's not always useful. Don't try. It's not always going to be practical to try and implement macros when it's not really necessary with a specific model. So no, make a decision early on. It's like, okay, do I really need this tool? Do I need a tool for what I'm really doing here? If not, then don't use it. You don't need to. Also, the biggest takeaway, like learning any new software tool, any new language, or any new capability with your existing software tool, the best way to learn is by practicing, doing what I did here over and over again, and doing the examples that I did here, redo them, do more examples, try to find other examples, maybe try with other languages like with Java or JavaScript. Practice is the best way to learn this stuff. That's you can watch this lecture a dozen times and not learn as much unless you do it yourself. And with that, thank you for listening to the ACSI lecture series on automating SysML. And with that, good luck, everybody, and have fun.